In Module 11, Section 5, we will look at rationalizing denominators of radical expressions. Many times it is helpful to rewrite a radical quotient with the radical confined to only the numerator. If we rewrite the expression so that there is no radical in the denominator, it is called rationalizing the denominator. This process involves multiplying the quotient by a form of 1 that will eliminate the radical in the denominator. Let's try an example. We want to rationalize the denominator of the expression square root of 3 over square root of 2. Now the process we go through is pretty much straightforward. We want to make sure every square root is simplified first. And in this case, we have the square root of 3, which is prime. That's not going to break down any further. The square root of 2, 2 is also prime, so we're good. Each square root is simplified. When we're dealing with square roots, we will multiply the top and bottom by the square root of the denominator. So square root of 2 over square root of 2. When we do this, in the numerator we have square root of 3 times square root of 2. We are both underneath the radical, so we multiply underneath the radical. That gives us square root of 6. In the denominator, and I'll go ahead and write it this step from this point forward. I'll show you the short way to write this. Square root of 2 times square root of 2 is the square root of 4. But we should know that the square root of 4 is 2. So the square root of 6 over 2 is the answer. Anytime you multiply a square root times itself, the square root falls off. The square root cancels out. We're left with just the radicand, just what's underneath. Now, in the case of a cube root, we have to work the problem a bit differently. Here we have 6 over the cube root of 9. The first thing we need to do is, number one, make sure that the cube root is as simplified as it can be. We look at the prime factorization of 9, which is 3 times 3. We don't have 3 identical factors we can pull out. And so there's nothing that we can take out from underneath the cube root, but we do want to rewrite 9 as 3 squared. And you'll see why in just a moment. So we looked at the prime factorization. We're going to rewrite this as 6 over the cube root of 3 squared. Now in the last example, I'm going to go back to the last example for just a moment. The reason the square roots of 2's canceled when they multiplied together. The first 2 has an exponent of 1. The next 2 has an exponent of 1. And remember, the index of the square root is 2. When we multiply these, we write that 1 square root, so the index is 2 still. Remember, when we have the same base, we add the exponent, so this becomes 2 squared. And the index and the exponent cancel. Whenever we can get our index and exponent to match, it's going to make the square root or cube root or fourth root cancel out. So going back to our example, we have the cube root of 3 squared. We need to turn our exponent of 2 into an exponent of 3. The way we do that is like this. We're going to multiply by some sort of cube root on top and bottom because we already have a cube root. Because we started with a base of 3 underneath, we still need a base of 3. But we need to choose our exponent carefully so that when we multiply the 3 squared and the new 3 to some power, it will become 3 cubed. So we're going to choose 3 to the first power on top and bottom. When we do this in the numerator, we have 6 on the outside, so it becomes 6 cube root of 3 to the first, or just cube root of 3, over. When we multiply underneath the cube root, we have 3 squared times 3 to the first, which will give us the cube root of 3 cubed. And just like we wanted, the index and the exponent match, so they cancel. And this becomes 6 cube root of 3 over 3. And look what else we can do. We can simplify the 6 on the outside of the cube root and the 3 in the denominator, which is not underneath the cube root anymore. 3 goes into 3 one time. 3 goes into 6 two times. So this becomes 2 cube root of 3. Here we have another example. We have the square root of 7x over 3y. Using the quotient rule, this becomes the square root of 7x over the square root of 3y. We look at each radical and we determine that 7 and 3 won't break down. The x to the first power, y to the first power, we won't be able to simplify any of the radicals. So because we have a square root in the denominator, we multiply top and bottom by the denominator exactly how we see it. In the numerator, because 7x and 3y are both underneath the square root, we rewrite this as 7x times 3y, which becomes 21xy, over. Now in the denominator, we don't have to write the square root of 9y squared. We know that a square root times itself The square root falls off, and we're left with just the radicand. Many rational quotients have a sum or a difference of terms in the denominator rather than just a single radical like we saw in the last few examples. In that case, we need to multiply by the conjugate of the numerator or denominator, whichever one we are rationalizing. And the conjugate uses the same terms, but the opposite operation. So instead of a plus sign, it will use a minus sign, and instead of a minus sign, it will use a plus sign. Let's try a few examples. So we're going to rationalize the denominator again, but as we see, we are adding in the denominator, which is different from the last few examples. So the way we will eliminate these radicals is by multiplying by the conjugate. We look at the terms in the denominator. We had a plus sign, we're going to use a minus sign. So square root of 2 minus 3 in the numerator and denominator. Now in the numerator, we actually have to FOIL. In the denominator, something special happens, and we'll look at that in just a moment. So in the numerator, we draw our FOIL arrows first, outer, inner, and last. And we work out these products. Square root of 3 times the square root of 2, that's our first product, becomes square root of 6. Outer product, square root of 3 times negative square root of 3 is minus just 3. Remember, if we multiply square root times itself, the square root falls off. The inner product, 2 times square root of 2 is plus 2 square root 2. And the last product, 2 times negative square root 3 is minus 2 square root 3. Now let's talk about the denominator. Anytime we multiply conjugates, it's a special type of FOILing. It's the difference of squares that we've used before in modules 5 and modules 9. We can ignore the outer and the inner parts of our FOIL and look at just the first and the last, because the outer and the inner will actually cancel out. So if we look at our first, square root of 2 times square root of 2 is just 2. If we look at the last, square root of 3 times negative square root of 3 is negative 3. Anytime we multiply square root by itself, the square root falls off. So if we continue to simplify, we have square root of 6 minus 3 plus 2 square root 2 minus 2 square root 3 all over 2 minus 3 is negative 1. Anytime you take a group of expressions and divide them all by negative 1, basically we're just changing the sign. Square root of 6 divided by negative 1 is negative square root 6. Negative 3 divided by negative 1 is positive 3. 2 square root 2 divided by negative 1 is minus 2 square root 2. And the last term, negative 2 square root 3 divided by negative 1 is positive 2 square root 3. As we look at all four terms, we have no like terms. We have a square root of 6, a square root of 2, a square root of 3, and a constant. So this is actually the answer. Let's try another example. Here we have square root a minus 5 all over 2 square root a minus square root b. Because we have subtraction in the denominator, again, we want to use the conjugate. So we multiply top and bottom by 2 square root a plus square root b. We change the sign in the middle, but we use the same terms. In the numerator, we're going to FOIL again. And in the denominator, we'll do our special multiplication. Numerator, we draw our FOIL arrows first, outer, inner, and last. Let's look at those products. The first product, square root of a times 2 square root of a is 2, and the square root falls off, so just 2a. The outer product, square root of a times square root of b is square root of ab. The inner product, negative 5 times 2 square root a will be negative 10 square root a. And the last product in the numerator, negative 5 times square root b is minus 5 square root b. Okay, so we're finished in the numerator. Now we go to the denominator and we do our awesome special product where we can ignore the outer and inner terms. So we do our first product, our last product. When we multiply the first, 2 square root a times 2 square root a, 2 times 2 is 4. Square root a times square root a is just a. Remember, the square root falls off when we multiply it twice. We then look at our last product, negative square root b times positive square root b is minus b. We look at the numerator, we have no like terms. Look at the denominator, there's nothing we can factor. So again, we are finished, and we have successfully moved all of the square roots from the bottom of the fraction to the top.